Hello everyone, my name is Adrian and I'd like to show you today how to use the Ubabuga text generation web UI open source project to run LLMs on Hyperstack. They have a great UI that I can use to interactively prompt the models and get some responses, which is a great playground for testing new ideas. And I know I want to try a couple of models. I want to go with Mixtral 7x8 and LLaMA 70B, which are two very strong open source models. So the use case is going to be summarizing a transcript. So here is a video from Ilya Sutskever talking about how next token prediction could be enough for AGI. Now this is possibly highly contentious, and I would like to make a summary so that I can run it by my friends in the community and we can start a great discussion about that. So that's kind of the goal. Now I know that I want to put this transcript and have a model summarize it for me. And for that, like I said, I want to try Mixtral and LLaMA 2. So let's see how we get about doing that. One of the main things that we get as questions is how many GPUs do I need? So for that, I found this page from Eloither AI, and they run some numbers about the memory requirements for different models. So I got a formula here, which says that for floating point 16 and BF16, this is the formula, 2 bytes per param by the number of params. But it turns out that we need another 20% for forward pass in the inference phase. So in the end, it would be like 1.2 by the model memory. Okay, so that's kind of the formula. Now, how much is my model going to take? Like I said, I'm going to focus on LLaMA 270B and Mixtral 8x7B, which is a mixture of experts model. From these two, the larger one is going to be LLaMA 270B. So let's do some quick math. I bring up the calculator, and I know I'm going to have 2 by 70. It's going to be 140 by 1.2. I'm going to need 168 gigabytes of memory. Now, for this one, I really want to leverage GPU acceleration. So how many GPUs am I going to need to fit this model? First question would be, what kind of GPU do I want to use for this task? And the answer is this NVIDIA L40 GPU, which is a very versatile GPU that works great both for graphics and AI workloads. Particularly inference is going to work just fine. For larger AI workloads, we would go to an A100 or an H100. But for this particular use case of a playground where I want to try models, I think the L40 is going to do just fine. Now go to the specs, and I see that we got 48 gigabytes of GPU memory per card. So coming back to my calculations, I need to divide by 48, and that will give me 3.5 cards, which in this case will round up to 4 cards. So there you go. By choosing the model and by choosing the card, then I know I'm going to need 4 L40s. That sounds great. So let's go to my dashboard at Hyperstack, and let's try and deploy a new virtual machine. We're going to call it LLM inference. And let's go to the Canada region, and let's search for the L40s. And sure enough, I have this 4 times L40 configuration. I could also get 8, but for this particular use case, 4 is going to be just great. So this is my selection of flavor. I'm going to go with Ubuntu. I have already set up my keys. I need the public IP, and I think I'm good to go. So I click deploy and wait for the VM to be deployed on my behalf. Okay, my virtual machine is now ready and I have enabled SSH access. So let's go directly to the console and SSH into the machine. Right, let's quickly check if we've got the GPUs there, recognizable by the system. And sure enough, we've got 4 times L40s with 46 gigabytes of GPU memory. So this is looking fine. Let me try and get the URL for this Uba Booga text generation web UI. Let me copy the repo URL and let's fetch it. All right, we have now cloned the repo and we're ready to get started with the UI to test large language models. If we go back to the repository of this open source tool, we can check in the README how to start the GUI. And we have different commands here for different operating systems. And here below, we have different flags. Since we are on Linux, then we're gonna use start Linux with some parameters. And I have already prepared that. So let me fetch it for you. There you go. We can go like this. So start Linux means that we are on the Linux operating system. Share is going to create a URL that I can use from my local environment to access the VM. And now the interesting part here is GPU memory, where I'm specifying how many GPUs I'm going to use and how much memory do I want to allocate in each of them. So in this case, I want to leave a certain margin, not to saturate each of the GPUs. And in any case, it's going to be just fine for the models that we're going to run. So the key part here is to give 4 numbers, which we need to indicate that we're going to run over 4 GPUs. So let's try and run this installer. It installs a code environment and it fetches certain dependencies. This is interesting. Now it's asking me what kind of GPU acceleration do I have? In this case, these are NVIDIA GPUs, so I go with A. And I'm not using an old version, so I can go with no. Okay, the installation has already finished. The second time you invoke it, it will be much faster because it doesn't have to pull all the necessary dependencies. It already has them. The important piece here is that a URL has been created where I can access the GUI. Remember that by the time that you watch this video, this URL will no longer be valid, but you can create your own by following this procedure which I'm showing you. Okay, so I go to the browser and I enter the URL. Okay, and here we are in the chat window where I can start typing messages, but not just yet, because we haven't got any models yet. We have to download them, and we can do so directly from this phenomenal project. But before we download the models, let's check what's the storage situation in our virtual machine. So let's stop the execution for a moment and let's check the available space. And here we can check that mounted on the root directory, we've got gigabytes of storage, and that won't be enough for storing these really large language models. But we have much larger partition here at ephemeral in the order of terabytes. Remember that you can always check those details in the help page of Hyperstack. Here I have located the information for the L40s, which is what we're using. And we are on this flavor, L40 by 4. And here it says that we have 3,200 gigabytes in an ephemeral disk, as we just saw over here. Okay. So let's open another terminal window and let's log in there. Okay, let's create a new folder which is going to be in the ephemeral mount point. It's going to be called models. Let's make sure that we assign it to our user. And now we need to tell our UI where our models will be downloaded. There. So we start again, and you will see that this time is much faster because it has already collected all the necessary dependencies. Okay, this is the new URL. Every time we start, remember that we need to update our URL. And now we are ready to download our models. So we can locate them in the Hugging Face hub and just copy their description here, paste it here, download, and we can check that we are effectively downloading in this path over here as we specified. And like that, we're going to ensure that we have enough space for these large language models. All right, our model is done downloading and is ready to use. But let's fetch the LLaMA model to go as well, and then we will compare them side by side. With LLaMA, it's a little bit more complicated. First, you need to get access through the form that you will find in the Hugging Face page. In this particular case, I have already got that access, as you can tell here. This is just to say that LLaMA 2 is a gated model. It's still open source, but you need to have a filter by Meta first for access. That means that every time we fetch it, we need to provide our identity. And for that, I can go to my profile page in Hugging Face and see the access token. I have already created some access tokens, and a read access token will be just fine for this purpose. So I can copy it, and back to our terminal, I can stop our UI again and say export Hugging Face token, read it like this. I'm going to paste it away from your view there. And now all I need to do is call our GUI again. We grab the new URL, do as we did before. And now, because I have given my Hugging Face token, and because I am already granted access at Hugging Face for this model, then I can fetch it as we did with Mixtral. And we can check the progress here as we did before. Okay, we have downloaded now our LLaMA 270B chat model, and we're ready to try these models. So let's make sure that we load them here, and let's start with the LLaMA 2, for instance. And now let's load it. And we have now loaded the model, but let me show you something really interesting. If we go to another terminal, let's install this little app called MVI Top. And you can see effectively how we're occupying the 4 GPUs with our LLaMA 270B model. It's a massive model which is taking 4 GPUs, almost to the 70% capacity. And as you read at the beginning, in the Elloither document, we're saving some capacity for the forward pass for inference. So like that, you can check the utilization of your GPUs. And now the model is loaded, and we are ready to take it for a spin. So we can go now to the chat tab, and I have already prepared the prompt. Remember that our goal here is to try and get a summary from the transcript of the video of Ilya Sutskever talking about next token prediction. So I have the prompt here prepared, where I'm asking for a summary of the main ideas of the transcript, which I copied directly from YouTube. So let's see what LLaMA 2 does about it. And we can see how the GPUs are being utilized during the forward pass for inference as the tokens get produced. All right, let's check the answer. It did take the information we gave it. And that's pretty good. Maybe a bit too verbose and too formal. So let's try and ask it to rephrase it. And like this, we can use the models in the familiar conversational manner that we're used to from ChatGPT, right? But this is completely hosted and managed in our VM, which is pretty cool. This is quite good. I think it's fit for sharing in the community. Let's check some stats here. And then we saw some stats about the generation and the number of tokens that were generated, the speed. We were about nearly between 4 and 5 tokens per second, which is quite decent given the large model we're dealing with. And let's try now the other contenders. And it's loaded now. So let's go back to our chat. Make sure we initiate a new one from scratch. There. And let's just copy the same prompt. And again, we see the GPUs working away on the token generation. Okay, I think it's pretty reasonable. We can have another go. And by the way, this is using the default setting of 0.7 temperature, which I think is fine for this use case because we want the model to have a little bit of flexibility in the output that it's producing. As you know, more temperature will generally mean more variation in the outputs. Right, this is looking quite okay. And so both are producing quite decent responses. An interesting aspect to observe is that is about twice as fast Mixtral over LLaMA 2 over the same hardware and for a similar level of quality. And today the scope was mostly just to get our setup working, And in the next video in this series, we'll dive a little bit deeper into comparisons of LLaMA 2 versus Mixtral, different use cases, and a deeper speed of inference profile. So until then, stay safe and thanks for watching.